Okay, this is 9-3, solving inequalities with absolute value. Okay, the absolute value of x is less than k. This means x is less than k, or I can do the opposite. X is less than, but because I'm going to set it equal to the negative value, I have to flip the sign around. When I'm setting it equal to that negative value, notice, because I took the negative, I have to flip that sign, inequality sign around. Is that clear? Okay. Same thing's going to happen here. X is greater than k, but because I'm in an or statement, now please make sure you're writing this exactly. Or goes with the greater than sign, and is with the less than. X is less than negative k. Now notice, again, one more time, because I'm setting it equal to the negative, I have to switch the sign from that direction to this direction. Are you noticing that? Because it's the opposite, I have to switch the directionality of the sign. Ben?
Wait, so why is it the less than for or and greater than?
Well, I'm going to explain. Okay, so notice the less than is an and. An and is a what?
It's a combination? No. Conjunction.
Yes. Nope, an and is not a disjunction. Yeah. It's a conjunction, and it is an intersection. It's an intersection. So less than every time we say is a and statement. Every time the less than symbol is touching the absolute value, it's an and statement. It's a intersection. It is a conjunction. A greater than is an or statement, which means it is a disjunction. This is a disjunction. Or it's also a union. Okay? Whereas this one is a conjunction. Or an intersection. Okay? Notice when the less than is touching the absolute value, we say less than. When the greater is touching the absolute value, we say great or. So ors are greater than, go with the greater than symbol. Anytime you see a greater than symbol touching the absolute value, that is a disjunction. Anytime you see a less than touching the absolute value, it is a conjunction or an intersection. Okay, questions? Ben?
I'm kind of confused. Like, how is it like touching the absolute value?
Well, isn't the point the less than part next to the absolute value? Whereas this big greater than part is close to the absolute value. So if it were turned around, I would read from the absolute value.
Wait. But why are you switching the signs?
They're two different situations. You're not switching them. Okay, let's move on a little bit, and I'll come back to that. Okay. Yes, Piper.
Where did they come up with Greator and?
I don't know. It's just this teacher who made this. Okay, is this an and or an or statement? Number 1. Everybody. It's an and statement. Okay. Why? Less than. Okay. So, as I go to graph this, right, I'm going to set it equal to x is less than 5, but then I have to set it equal to the opposite, so I have to switch the inequality sign around. And then we graph it. Even if you didn't know the and was there, once you graph it, you will see. X is less than 5, and x is bigger than negative 5. That and tells you if it's an intersection or a union. Okay. Number 2. Okay, so how am I going to split this one? What's it going to look like? How about Michael?
Going to be or statement.
It's going to be an or
So
statement.
it'll be x is greater than 5 or x is less than negative 5.
Perfect. He flipped the inequality sign and he switched the value to the negative absolute value. Okay, next. I'm going to graph those. And it's an or statement, so is that an intersection or a union? Union. Is it a conjunction, disjunction? Okay, so it's the combination. So x is greater than 5. And x is less than negative 5. So it's any of these numbers forever on in this direction, and any of these numbers forever on in this direction. Yes.
How would you word that? How would you say it in words?
X is any number less than negative 5, or x is greater than 5. You would use this in your words.
Oh, okay.
Okay? All right. Next. This gets a little sneaky. And upon my first period, right away they wanted to jump to absolute value but can't be negative. But remember, you have a less than or equal to sign. So let's just, is this an and or an, let's just go through the motions and see what we have. Because if we graph it, it may tell us a story. So is this an and or an or statement? Sarkis. Okay, that means it is a or a intersection. Yes. So I just split it. X is less than or equal to negative 2. But then I have to account for the opposite value. This could be a positive value too. And x is greater than or equal to 2. So, as I go to graph this, we said and is an intersection. That means what area do they have in common? So x is less than, x is greater than 2. What area do they have in common? Huh? No area. There's nothing in common here. So what do we say? No solution. Okay? Because an and statement, less than, means it's a conjunction, an intersection. Is there any area where this and this have numbers that are the same? No. So we have to say there is no intersection between those two sets of numbers.
Oh, okay.
Yes.
Can you also figure it out because anything absolute value is not less than a negative?
Okay, anything absolute value will not be less than or equal to a negative.
So right there you can solve
You
it.
can know that, but what this does is it proves it with a picture. Okay, next. Let's try the next one. Can absolute value be bigger than negative 2? So that we're gonna have some solutions. Can absolute value be equal to negative 2? No, but the other end proves correct. Okay, so I split it. X is greater than or equal to negative 2. And then or X is less than or equal to the positive, the opposite. Since I'm dividing it both sides since I'm dividing it by a negative, I have to take the opposite inequality. Now notice this is different. Instead of negative 2, it's positive 2. So if I'm taking the opposite number, I have to do the opposite inequality. Okay, and now let's graph that. X is bigger, anything. Now, this is an or statement, great to or. What does that mean? It's a disjunction. What does that mean, disjunction? Luke, it's a union. It's all these numbers or any of these numbers. It doesn't need to be both. It could be one or the other. So it's a combination. So here is X is greater than negative 2. All numbers forever and ever in that direction on the number line. Okay, next one. X is less than or equal to 2. All numbers forever and ever in this direction. So what set of numbers is in that final set? The union of those two inequalities. Luke. Any real number is a solution. Any number in the real number system. Okay, questions?
Yeah, on the test, if we write the x's such that, then can we get like marked up?
No, Mark, given extra points. No, it depends on what it's asking for. I'm going to hold you accountable to the directions. So if it asks for set builder notation in part A, you better put set builder notation. If you mix it up and put set builder in part B, I'm going to think you don't know what set builder is. Do you understand? So if I say, please write the answer in A, set builder notation, and B, roster notation, if you put set builder under B, you'll get that wrong. Okay? All right. Just listing the numbers. 5, 4, 3, 2, 1. Roster notation is just listing the numbers in the set. Set builder notation, yes. All right. Let's keep going. Now, absolute value inequality, absolute value, solving absolute values. So in this case, we have to do what? What are we doing, Rogelio?
Gotta separate it.
Separate it. Why don't you guys try this one on your own? Do you think you can do this one on your own?
Yeah.
Maybe.
Try it. All right. Oscar, start us off. First of all, Oscar, tell me, is this a disjunction, conjunction, union, intersection?
You have to put an and.
It's an and statement. Is that a conjunction or disjunction? Is that an intersection?
Conjunction.
Conjunction, is it an intersection or a union?
Intersection.
Perfect. You know what? You just take it a piece at a time. Don't look at the whole thing overwhelmingly. Just answer that question one at a time. Okay, so we know that it's an and statement, and it is going to be an intersection. That's the part you have to get out of that robotic state of math and make sense of it. Okay, so what do I do first, Oscar?
You would put x minus 5 is less than 3.
We write the first one exactly the same.
And the next one would be x.
And what word do I put in the middle? And. Okay, and then the next one's going to read.
X minus 5 is greater than negative 3.
Is greater than. He switched the inequality sign and he switched the sign for positive negative 3. Okay, now what would we need to do, Lucy?
On the left, you're going to add 5.
Add 5 to both sides of the equation.
And on the right, you're going to add 5 as well.
And we end up with the first equation. Let's fit inequality.
X is less than 8
X is less than 8. And the other one?
is going to be x is less than 2.
Okay, add 5.
It's not less than.
It's greater than 2.
Greater than 2.
Greater than 2.
Okay, as I graph, we can do that as an in-between, or we don't have to. We can avoid that. That's not mandatory. But as I graph, it starts at the 2, and it goes all the way to 8. Now, I'm going to tell you on a Chapter 4 test that I was grading. So it starts here. Ugh, don't do this. Okay.
Can't you write on the board?
So on here, it starts at 2 and goes all the way over. On the Chapter 4 test, look what I had. I had something like this.
Doesn't show anything.
Oh. There we go. I had this. What's wrong with this statement? Andre. There's no 0 in the number line. Okay, what else? Michelle.
2 comes before 8.
2 comes before 8. Don't put your numbers on the number line in the wrong order. I promise I will mark it wrong. Make sure you can make sense of that number line. Okay? No half points there. It's wrong. All right. So next problem. You guys want to try that one on your own?
Yeah.
Okay, let's try it. Branch it out. Pause the recording. Okay, let's check our work. Hopefully you branched it out. It's getting wonky on me. Add 3 to both sides. And we should be left with x is greater than or equal to 6, or when I graph it, it should be in 2 different directions. Question.
Yeah. I got everything up to that. Like, I know how to graph it, just when to draw the line. I don't understand. How do you know which way to go?
Because x is bigger. Shh. X is bigger. Can you read that symbol? Bigger or equal to 6. On the number line, which way do the numbers get bigger? To the right of 6 or to the left?
The right.
To the right. Then we make sense of this one. X is smaller or equal to negative 3.
Okay.
Where do the numbers get smaller on the number line? To the left. Does that make sense?
Yeah. And then
Okay.
When they go like there's two points and they go towards each other and like it's just one line. When do you use that? Like,
When it's an and statement.
oh.
Okay? So you got to make sense of that, or an and. Okay. Now, actually, I'm going to split this into 2 different equations. I'm going to make... Okay. Sorry, it's going so wonky. Okay. Pay close attention on this one. This is where the mistakes happen. Okay, so on the first one, what would we do first to simplify this? Nicole?
Add 6.
We undo our adding and subtracting first, and we are left with 2 times the absolute value of x minus 4. Is less than or equal to 16. Next step, Kiana.
Divide both sides by 2.
And we are left with the absolute value of x minus 4 is less than or equal to 8. Now, this is the point when the absolute value is alone. This is the point where you determine if it is an intersection or a union, a conjunction or disjunction, an and or an or statement. Okay, Sarah. It's going to be an or statement. And so we have, because it's, wait, why did you say or?
Oh, and.
It's going to be an and statement because it's less than. And so we said it x minus 4 is less than or equal to 8. And we have x minus 4 is greater than or equal to negative 8. And then we solve. Okay? And then I go plus 4. X is less than or equal to 12. And
X is greater than or equal to.
nothing's writing. X is greater than or equal to negative 4. I'm going to draw my equation. Whoops, it's not showing up.
There's a lot of bad conversation.
Okay, hold on. Okay, so we've got negative 4 here. I have a 0. I have 12. It's an and statement, so it's an intersection. It's bigger than negative 4. X is greater than or equal to negative 4, so it's a solid. X is less than or equal to 12, and it's one line because that's the only area they have in common. Yes.
Well, why is it 12?
Because 8 plus 4 is 12. I added 4 to each side.
Oh, it said 1.
Sorry, you know what?
My bad.
It stopped recording that. Sorry about that. Okay, now, let's make a different problem. This is where the mistakes happen. Let's say it's negative 2. You with me? Absolute value of x minus 4 minus 6 is less than or equal to 10. I add 6.
It's not working.
Oh.
It's getting old.
Okay, so I'm going to add 6. I'm going to do this on the board. Ugh. Okay, so I add 6 to both sides. I'm left with negative 2 times the absolute value of x minus 4 minus 6 is less than or equal to 16. Oops, I shouldn't add this.
Oh, there.
Shouldn't have the negative 6. I already got rid of that. Okay, so now, this time I'm dividing by negative 2. Dividing both sides by negative 2. When I do that, what happens?
You have to flip it to a greater than.
And now I'm left with my absolute value. And I'm left with negative 8. Okay, now, this is where we decide if it is only when you get the absolute value alone do you determine if it's a conjunction, disjunction, union, intersection. So now, what is it? An and or an or statement? It's an or statement. So now we've got, x minus 4 is greater than or equal to negative 8, or x minus 4 is less than or equal to negative 8. Add 4. We get x is greater than or equal to negative 4. Or add 4. Oops.
Isn't it supposed to be right?
Whoops, it should be a regular 8, yeah. That should be a regular 8. Okay, x is less than or equal to 12. Okay, now let's look at that graph and make sure this makes sense. If I were graphing this now,
It's not showing.
I know, it's not showing here either. Okay, what are the two numbers we have? Negative 4 and positive 12. It's an or statement. So it says x is less than or equal to here. So I have a solid 1 at the 12. It's any number in that direction. And then I have x is greater than or equal to. So it's any number in that direction. So what is the solution there? Yes.
It's all real numbers.
All real numbers. So, one more time, let's go back to, this is what I want you to notice here. It's only when the absolute value is all alone that you can determine if it is a conjunction disjunction. Do you understand that? You don't get to say right away in the beginning, because you see this, it's going to be an and statement. You got to wait till your absolute value is all alone to determine that. Yes?
Okay, back to the problem in red. How come it's only negative 14 to 12, and on this blue problem it's all real numbers, but it's the same?
Because this,
Oh, or an and. Okay, I understand.
this is an and, it's an intersection. It's only the numbers they have in common here. And this right here is an or statement. It's all real numbers, all these numbers and all these numbers forever and ever in those directions. Okay, that is the end of the lesson.